Hello guys, welcome back to my channel Arrow Beast. In this lecture we will discuss about work equation for the various process, means displacement work. So as we know that work is equals to V1 V2 integration of P dV. Work is equals to, as we know that work is equals to force into displacement. Into displacement, and the work is equals to PA dx, and PA dx, that is area into displacement, and area into displacement is equals to change in volume. Therefore W is equals to P dV, that is integration V1 V2. So going with the first work equation, that is a constant volume process. This one is V is equals to C. It is also known as isochoric. So going with the graph for constant volume process, this one is pressure and this one is volume. Okay, this one is a graph for constant volume pressure. This one is 1 and this one is 2. From 1 to 2 it comes, and the W is equals to, from 1 to 2 is equals to work V1 V2 integration of P dV is equals to 0, because V1 is equals to, here V1 is equals to V2. V1 is equals to V2. So work done is equals to 0 in that case. So second one is constant pressure process. P is equals to C. P is equals to C. It is also known as isobaric. So going with a graph for constant pressure process, here is the pressure and here is the volume. So for constant pressure process, like that graph will come. This one is volume 1, this one is volume 2, this one is pressure. Here P1 is equals to P2 is equals to constant, means here pressure remains constant, and in that case volume remain constant. Okay, then work done is equals to V1 V2 P dV. So W is equals to P V integration for V from V1 to V2, that is P V2 minus V1. So we have PV is equals to MRT. So we have PV is equals to MRT. Therefore M is equals to MR T2 minus T1. Here M is equals to mass in kg. Mass in kg. This is the constant pressure process. So third one is constant temperature process. So going with the third one, constant temperature process. In that case graph will come like that in curve. Here P pressure or volume, graph will come like that from 1 to 2. This one is PV. PV is equals to constant. Pressure and volume remain constant, in that case constant temperature process. So work done is equals to V1 V2 integration of P dV. As we know that PV is equals to constant, PV is equals to constant, therefore P is equals to C upon V. Then we have to put the value of P in this one equation, V1 V2 C upon V dV. C is constant, therefore we have to remove the C, therefore V1 V2 1 upon V dV. Therefore integration of 1 upon V is a log of natural log of V from V1 to V2. So W is equals to C natural log V2 upon V1. Therefore, as we know that PV is equals to C, therefore P1 V1 is equals to C, and P2 V2 is also equal to constant. Therefore, this one is equals to P1 V1 is equals to P2 V2. Therefore, W is equals to P1 V1 natural log of V2 upon V1. Therefore, W is equals to P2 V2 natural log of V2 upon V1. Or W is equals to P1 V1 natural log of P1 upon P2. So here W is equals to for P2 V2 natural log of P1 upon P2. This is the equation for constant temperature process. So going with the fourth one. Is adiabatic process. Fourth one is adiabatic process. Here V is equals to constant. Going with the graph, it is like that: pressure, volume, graph from 1 to 2. Here V is equals to constant. So W is equals to work done is equals to V1 V2 integration of P dV, and PV is equals to constant. Therefore P1 V1 V is equals to constant, and P2 V2 V is equals to constant. So P is equals to C upon V. Therefore W is equals to C V1 V2 dV upon V whole raised to power V. Therefore, as we know that x raised to power n, integration of x raised to power n is equals to x raised to power n plus 1 divided by n plus 1. Here we have to apply this one formula. So W is equals to C V plus 1 negative V plus 1 V2 V1. So W is equals to C negative V plus 1. So V2 V negative V plus 1 minus V1 negative V plus 1. So W is equals to 1 upon negative V plus 1 P2 V2 V2 minus V plus 1 minus P1 V1 V1 minus V plus 1. Okay, and then W is equals to P2 V2 minus P1 V1 divided by negative V plus 1. So W is equals to P1 V1 minus P2 V2 V minus 1, or MR T1 minus T2 divided by V minus 1. This one is the equation for adiabatic process. And fourth one is a polytropic process. So polytropic process. Here PVN is equals to constant. Therefore, same procedure we will follow like adiabatic process, but at the place of V we have to put the value of N. At the place of V we have to put N. P1 V1 minus P2 V2 divided by N minus 1, like that, or W is equals to MR T1 minus T2 divided by N. These are the work equation for the various components. In the next video we will discuss the problems. I hope you like this video and do subscribe my channel. I'll bring more notes in the next video, so thank you.